What's up, computer integrated manufacturing? This is Mr. Wyckoff coming at you from Olympic High School. Today we're going to set up the Benchmill 6000 and run a base part of the container design project from a student who designed a Fox box. So basically he changed this or shaped this material from stock into a Fox looking box, and here's his top. So very creative, very innovative, did something original, a little actually a lot different than the tutorial I came up with for my container project in the CAD/CAM videos that I shared with you. So here we go. As you can see, we did a verification. The code works. He designed it in Autodesk CAM and it verifies in CNC Motion for the Benchmill 6000. So let's start from scratch and begin this process. Okay, so you've got to turn the machine on. 1 is on, 0 is off, okay? So right now I have it on. You also need to power up the air compressor. So our air compressor is inside of our closet, so we can cut down on the decibels or the noise pollution in class, because this thing, it kicks on all day long, on and off, and it's very distracting. So I've already turned it on. Again, 1 is on, 0 is off, and basically maintaining 80 PSIs on the regulator pressure and around 120 in the tank pressure. So once that decreases, it'll kick back on naturally and go basically back up to these 2. Now, some maintenance awareness. I do on a regular basis take this out and leak all the moisture and water out of it. There's a obviously I do that after the air is completely out of it, and I leak it into a floor drain. So that's kind of some maintenance awareness. So pressure's on. Okay, so the air pressure's on. The pneumatic shield is up, and that obviously if there's not enough air pressure, this shield would be closed completely. So you don't, you want to maintain air pressure, or this shield will close on you. I can manipulate open and close right here. Shield open, shield close. You can hear the air pressure controlling that system. I do have a pneumatic vise, but I don't use the pneumatic vise. It's just by preference. I like to use a manual vise, so I disconnected the pneumatic vise. So that's primarily what the fluid power, the air pressure, is controlling. Okay, so the next thing is I want to make sure that the vise is square to the CNC table. This is the table right here, and I can control that table. I'm gonna back up a little bit so you can see, turn the camera up, and I'm just gonna jog the table so that you can see manually jogging it using this window right here. And this is jogged on the X, jogged on the Y. You can see that the table moves, and then on the Z. So again, we want to make sure the vise is square to the table. So I'm going to use a machinist square. That's one way you can do it. There's other ways, but that's how we're going to use it. Now, if it's not square, you're going to have major problems. It's not going to machine out properly. So just very important process to be aware of. And so I have a Allen set, and I'm going to see if I can zoom in for you here. Okay. All right, there you go. So I'm going to, you can set this vise up, tons of different ways, but I can loosen the vise here and tighten it back down with these different, standoffs. And I'm just going to check with the square right here, and I'm going to zoom in and what I'm looking for exactly. So there's no gap between the vise and the table. If it was not square, there'd be a significant gap. Okay, it'd be like this. So it's square, I can tell. Okay, just by that, and you know, I have this machinist square rested up on the table right here, and then I kind of just slide it back. So again, everything is looking square, so I don't have to loosen these with the Allen set and position it any differently than how it is. Okay, so the next thing is we're going to put our stock in. The parameters I gave you were 3 1/4 by 4 1/4, and this is actually 1.5 inches high, so that is plenty based on the constraints I gave you. And you can see behind me, you know, the part is actually made inside that volume. Okay, so 3 1/4 by 4 1/4. The 4 1/4 is on the X, and that's the max travel that you're going to have this way. So if you go any bigger, it's not going to work. And again, 3 1/4 on the Y, so from front to back. If you go any bigger, it's probably not going to work. So I cut this. It's not perfectly square. The only way to really make it perfectly square would be to put it on a manual mill and actually, you know, shave one side at a time, you know, and square it up. For what we're doing in class, not needed, but you know, if you're doing real parts, especially in aerospace, you know, in your higher level technical industries, you know, you might need a square stock and go into it a little deeper than that. So anyway, when I set this stock up, I want this side of the stock flush to the vise, because that's going to give me like a reference point. So I'm just going to jog it over a little bit, just so it's kind of out of the way of the tool. And to be honest with you, you could take this, hold this here, not on the blades because you'll cut yourself, but up here, and then hold this down, and then the tool release button will allow you to take the tool out. So I'm going to set the stock in, and I'm going to flush it up to the side of this side of the vise right here, and kind of zoom in for you. But see how this side is flush to this. Okay, that's going to give me a reference point. I can keep putting the same similar stock in and keep running these parts if I do that. Okay. So once I have it in, you know, I put pressure down here as I turn this vise, this screw. That's just so I can get a nice even grip on it. And you don't want to over tighten it, but you don't want to under tighten it because it'll fly out while it's running. So, you know, you shouldn't be able to pull this up, okay? But if you look on the side, you also really shouldn't see any part of the block popping up. Okay, so let's see if I can orient that. But you know, if I'm looking down here and put my head over here and looking on this side, I shouldn't see like the front edge popped up or the back edge popped up. It should all be flat. That's really important. If you don't pay attention to that, that could also impact your part. So I'm just looking in. To me, it appears that it's coming up a little bit on the front edge, so I'm gonna loosen it up again and just try to put more pressure down with my right hand and as I turn the screw. And I'm using, you know, a substitute parallels, but basically it's only gripping a small portion of the bottom of the stock, because my part's going to go down pretty close to the vise, so it could hit the vise if I don't have enough material above the vise to machine out the part. And a way to look at that would be to use a caliper. So let me show you that next. Whenever you're in the advanced manufacturing work cell, always have your personal protective equipment, safety glasses on. You need to protect your eyes at all times, especially you know, you've got really sharp objects, do not jeopardize and, you know, without having your personal protective equipment. Always have your safety glasses on all the time. Don't be caught in the work saw without your safety glasses on. Very important. Your eyes are very important. So I'm going to verify the height of my part by using tools, measure. I'm going to select the very top surface, and then I'm going to use the view cube to see the very bottom surface, okay? And it's going to give me a total of 1.2 inches. So I need to know, that, and I'll show you why. Okay, so I'm going to use a caliper now, okay? And I'm going to use the stepping part of the caliper to make sure that from the very bottom of the vise to the top of the stock, it needs to be larger than 1.2 inches, preferably much more than that so you don't run into the vise and crash the bit into the vise. So let's see if you guys can see that, but it's a total of 1.268. So I'm 68 thou above what I need. Okay, so it's very close. Okay, so I still would really monitor this machine process and make sure it doesn't hit the vise. You can stop it on the dime, either by selecting stop right here during the machining process, is usually how I do it. So if I hear it hitting the vise, as soon as I hear it, I hit stop and prevent a crash, a major crash. If you're not paying attention, listening to music, text on your phone, it's going to crash and you're going to be really upset. So don't do that. Okay, so now we're going to verify and scrub code. Verify means we're going to run our code and make sure it simulates exactly what we want it to be. And then scrubbing code is going in and finding any codes that aren't working and troubleshooting around those. Okay, because it's when you're post-processing to different machines, you know, the post-processor might not be as updated as it needs to be. So you need to have the knowledge from hand coding and just different G&M codes to be able to troubleshoot the scrubbing process. So first thing I'm going to do is select Window, Run and Edit Screen. It's just going to clear my screen so I can see it. And I'm going to load file, open my code, load it. And then this red button right here is our verification button. And so I can take this window here, and if this isn't the stock size that you need to have it, you need to right click and go to setup and go to stock option and make sure, you know, 4 1/4 and 3 1/4 are the parameters by 1.5 height. So mine's good, just make sure yours is good. Sorry, light goes off on a sensor. I'm not moving enough. Okay, so I'm just gonna enlarge that to just to the right of the code. And now I'm going to verify the code with this verification icon. So it says verify program, reference point has not been set on line N8. Okay, so it says G53G0Z0 right here. Ran your code, there's a problem with it. So I'm gonna just search G53G0, and I'm going to select this window to activate the window. I'm going to unlock the screen by holding Control L down, so it's going to unlock and I can edit. And I'm going to hold down Control F, the find tool, and find that G53. So G53, find next. So there's one at the very end of the code. I'm going to just delete G53Z0 there, find next. There's one on line 228. I'm going to delete that. Find next. It says no other ones are found. I'm gonna go to the top. I think it's skipped over this one because there's one right here where we first began. So I'm gonna delete N3 on that one. And now let's go ahead and re-verify and see if that solved our problem. Sometimes deleting doesn't solve a problem, but in this case, it might. So verify, F5 to continue after tool 1's in. Okay, now it's working. Now, so we ran tool 1. So we gotta make sure tool 1's set up in our tool library, and we gotta make sure that, we had tool 1 set up in the tool holder, okay? That's a whole nother process using a spanner wrench and a crescent wrench to loosen and tighten these down. So I've got tool 1 set up here in the physical world, and I've got tool 1 set up in the tool library. Because if I didn't, it would not simulate like this. So now it's rolling on line M1180, doing a tool change, M6, tool 2, and now it's asking me F5 to continue. So it's running tool 2, which here's tool 2. It's a longer length, 1/4 inch end mill, and it finished the end of the code, and you can see it did it with two tools, a 1/2 inch diameter end mill. Okay, that did the facing in some of the pockets, and then this did the 2D adaptive, the long shaft, which is the profiling on the side. Everything looks good. I think we're ready to run. So let's go to the next step. Okay, so I'm just gonna check my tool library setup. I'm gonna again select window, run an edit screen, just clear everything. Go to tools, library. This is where I'm setting up my tools that I'm using. So I'm using tool 1, 1/2 inch end mill is the most important part. And then tool 2, which is a 1/4 inch end mill with an offset. And this offset is really important because it's the difference between tool 1 and tool 2. So if that's not set up properly, then it's not going to machine properly. So let's go ahead and set up tool 1 first. But before we do, let's go ahead and just run homing process. So you have to do this in the beginning before you run your part. So I'm going to do a home, and it's just finding a X, Y, and Z location that the machine can reference. So when we set 000 on the corner of the stock, it can locate that properly. Okay, so now we're going to go ahead and set up tool 1. Tool 1 is our 1/2 inch end mill. It's secured in the collet and tool holder. I use a spanner wrench and a crescent wrench. I'll show you what those look like. So I actually secured this in a vise so that I could use 2 hands to use the spanner wrench and the crescent wrench to change out the tooling. Okay, so very important, we're working with sharp objects. So if you don't have your safety glasses on, get them on now. Also, this will blow dust around and can irritate your eyes as well. So I'm gonna hold this outside on the tool holder and on the collet, not on the blade to cut yourself. And I'm going to put pressure up while I push the tool release button in, and then let go of the tool release button, and it'll suck right up in the actual tool holder. So again, if you don't have air pressure, that's controlled by air pressure, so it won't work properly. So make sure you're maintaining proper air pressure. You might be able to hear it running in the closet. If it was out here, it'd be way louder. You probably wouldn't even be able to hear me. Okay, so now that we've homed it, we can use the jog control. So you can activate the jog control on your screen. So you can jog it, X, Y, and then Z up and down, okay? So you can use the jog control to do it, or you can use the keyboard. I'm gonna use the keyboard, okay? But in order to use a keyboard, you have to activate the jog control And just by activating it, you can just click one of these axes. Okay, so you know the left and right arrows, the X, the up and down arrows are Y, and then page down. No, I'm sorry. The minus is Z down, and the plus is Z up. Another thing to pay attention to are the speed settings. So if I lower the speed setting, it will not travel as quickly as you just saw. Or if I change the step size to 1,000ths, it, you know, which I will at some point when I get close to the stock and set up the tool, that will move in thousandths compared to continuous or tenths or hundredths place. Okay. All right, so I'm going to go ahead and jog it over to the side of the stock, and I'm going to bring it down. It's hard to get both in the. So I'm going to bring it down. What I want you to pay attention, I'm going to zoom in, okay, is there is a blade, okay? There's a blade sticking out, okay? So you want it to stick out and hit this stock perpendicular, okay? So as I bring it down and bring it closer, and at this point, I probably can go ahead and change the step size to, you know, you can bring it to hundreds and you'll see it get a little closer. And it looks like it's gonna hit soon, so I'm gonna bring it to a step size of thousandths. And thousandths, you know, a sheet of paper is like 3 to 4 thousandths, but not much more than that. So now I'm gonna get a piece of paper because I want it to be that accurate, okay? So I'm gonna get a piece of paper. I'm gonna slide it up between the cutter and the side of the block. And I'm just gonna move it back and forth as I go in on the X, and I'll feel it grab. As soon as I feel it grab, okay, it's grabbing. So I'm just gonna let go. I'm gonna go over to my settings. Let me zoom out so you can see. Okay, setup. I'm going to go to set axis to 0. And we want to set axis on the X, and we want this selected, this offset value, where this blue line represents the stock and that blade is touching the stock. So we want that selected. Now look, the tool radius is not that. So I'm gonna cancel. I'm gonna go to Tools, select Tool, and I want Tool 1 selected. This is a big mistake. If you don't do this, it'll mess up everything. So make sure Tool 1 is selected before you do that. Back to Setup, back to set axis to 0. Again, X selected, this configuration selected, and now the tool radius is 1/4 inch. I know it's correct, so I'm gonna go ahead and select OK. But as I do that, I want you to pay attention to this X value. Okay, it's gonna go 0. Or I'm sorry, it's gonna go 0 and then minus the radius of the tool. So that's correct. So next we're gonna do Y. So I can go back and select continuous, and I can jog over X, and I'm just going to select the left key to jog out, get the paper out of the way. And I'm going to select let's see if I can show you both here. I'm going to select the Y and bring it on the outside. Okay, I'm clearing, and I'm coming in the front of the block. Okay, now this is where I have to like put my head inside and look from a different angle. Okay, so I'm going to look over here at my Y axis, and I'm going to kind of bring the keyboard over so I can control it from over here. Okay, and I'm going to make sure and turn the blade in. I'll give you my perspective here. Okay, I'm going to turn the blade in, zoom in. So it's almost like that already. So you know, I just want to make that blade perpendicular to the side, so the furthest point out will come into contact to the front edge. Okay, so now that looks good. I'm going to go ahead and bring it in. It's super close. So now I'm going to back it down on the step size to probably tenths again, or hundredths place, I'm sorry. And I'm going to go a little farther in. It's hard to do it all with the camera. So we're super close, and now we're going to get the paper and do the same process over again. Okay? So put you down, get the piece of paper. Go ahead and put it inside here. And with one hand, I'm going to move the paper back and forth. And the other hand, I'm going to, I have to activate the window again and I'm going to select the thousandths step size over here because I'm super close. And now I'm going to go ahead and select this Y key. Oh, I need 3 hands. Okay. Select the Y key. And it is grabbing right there. Okay. So I'm going to let go of the paper. I'm going to go to, you remember? Setup. Access, set access to 0. Y configuration. This configuration, check marked, correct tool still selected, and then watch the Y value change minus the radius. Okay, so our tool 1 Y is set now. Okay, I'm going to go ahead and hit continuous step size. I'm going to use this Y key to back out. Okay, paper is out of the way. And then the last would be the Z. So I'm going to raise it up using plus. And then I'm just going to use the keys to go over anywhere on the top surface. And now I'm going to do the minus key, get close. Okay, so I'm pretty close. I'm going to put the paper in. I'm going to bring down the step size again to 1/1000 because we're super close. Same process, right? Same process, repetition. And as soon as it grabs, we know that's our Z. Okay. So it's grabbing. So I'm going to go to setup. Going to go to set axis to 0, Z, and say OK. And watch the Z go 0. There it is. All right, so now I'm gonna hit step size continuous, bring it up. I should be able to now do or send the tool to 0, 0, 0, and it should end up right on that corner. So you can do that from the home position. So you can just hit quick home. Okay, it's done homing. Now I'm going to do go to position. So the quick key, everything has a quick key, but go to is F8. Okay, so watch what happens when I select F8. So I'm going to select F8. The go to position window will come up, and now I can send it 0, and I'm going to hit tab on the keyboard. And I'm going to put Y as 0. And I'm going to hit tab on the keyboard. And I'm going to make Z 0. Now, you can go rapid or you can go at a slower feed rate. So you probably, if this is your first time, you should go probably a slower speed rate. But since it's not my first time, I'm going to do go rapid. But I'm going to have my hand on the stop button just in case if it runs into the part. I'm also going to be looking at these values and seeing if that matches up with this 0, 0, 0 corner. If it doesn't, I can prevent a crash by hitting stop. Okay, so we're going to go rapid because I've done this a million times. You should just go slow when it's your first time. So watch the relationships between the tool and the actual position here. See how everything was in relationship? So that's why I didn't hit stop, because it wasn't going to crash. So we know tool 1's set up properly. I'm going to send it back home, quick home, and now I'm going to put tool 2 in, and we're going to set up tool 2. Okay, so we're going to hold firmly on the collet and the tool holder above the blade, not on the blade, and then hit the tool release and it will drop out. So don't let it drop on your workpiece. I'm going to put it back in its position over here, and now I'm going to choose tool 2 because we know tool 2 in this case we chose 1/4 inch end mill. Okay, so now I'm going to put pressure up, push the tool release button, and then just kind of check, make sure it's not wiggling and it's secured itself properly. So we're going to do that same process of tool setup, but we need to, this is a big problem if you forget this. Got to go to tools, got to go to select tool, and you got to choose tool 2. Select tool. Or you'll erase all the settings that you just did on tool 1 and you'll be very upset with yourself. So don't do that. Okay, so now we're going to go through that same process, but for tool 2. Okay, so this is going to be a little different because this tool needs to have a offset difference between your tool 1. Okay, so I'm setting tool 2's Z now. Okay, now I'm going to go to tool library and I'm going to double check under tool 2 that there's a height offset. Okay, this height offset is in relationship to tool 1. Okay, so that needs to be done, and you can, so I'm going to remember 0.7887. Okay, because that's what was programmed in there before. So I'm just going to jot that down so I can remember it somewhere. All right, so now I'm going to select right here. Let's zoom in. the current Z. Let's see if that number changes much. It actually is the exact same, so that tells me that's the correct offset for that. Okay? So now, I'm gonna go ahead and say okay, and send that to Quick Home. And we're gonna go ahead and take tool 2 out and put tool 1 in, because that's what we start with in our code. Okay, so I'm looking at our code. In the beginning of our code, we use tool 1, so I'm gonna go ahead and put tool 1 in. Okay, so we're gonna go ahead and run this whole process. I'm gonna do an overview of the whole process. So if there's any troubleshooting I have to do, I'll stop, I'll slow it down and do that troubleshooting with you. If not, we'll come out with a part that hopefully looks just like this. Well, in green, because this was 3D printed, and we're making this out of high density foam commercial sign companies use for outdoor signs. So this is actually their scrap that they donated to us, because it would end up in a landfill if we didn't use the scrap for an educational purpose. Okay, so we're gonna go ahead and run it. So I'm gonna close these shields. Safety factor number 1. And I'm gonna select this green button, which is run. And if you, just before we run it, we can verify one more time to make sure we're still got the right code in before we run it. Make sure there was no mistakes. So that's what should happen first with tool 1. And then tool 2, F5 to continue. Looks like there's some extra processes in here that were unnecessary, but that's okay. I think it's still gonna create what we need to create. So it's ready to run. Go back to Window, run and edit screen, clear the screen, select play, run, F5 to continue. Here we go. So I can pause it at any time and evaluate what's going on, okay? Pause is right here. So I can see it's about to run the facing program. Okay, so I like what I see, and I'm gonna continue with play. Okay, so I like that bit. That's what it should be doing. It's a good sign that everything's good. Now notice, if you look at it, it's kind of deeper on the right side than the left side. That's probably because the stock itself is not sitting and seated in the vise perfectly flat. Now that could be a bunch of different reasons. You know, the vise, when I tightened it down, it lifted up the front edge, the right edge maybe a little bit, or the stock cannot be square, stuff like that. But at any time, oh, say, oh, I don't like that. Pause. Okay, because maybe your feeds and speeds aren't working. Maybe you're cutting full depths, and that's not going to be good. You know, so always use that pause button just to check and evaluate. All right. If you have to, hit stop. Okay. So we're going to keep going. Okay, so it's doing that outside pocket, I think or no, to the adaptive probably. That's what it's doing. Okay, I'll speed it up. All right, so for some reason, if you do not like the feed rates or the spindle speed, you can actually modify it manually. And this is the dial your settings in, you know, so if you're gonna improve the next run, you know, you can change your code and it'll update. So, you know, what do I mean by that here? So I can increase the feed rate up to 200%. That means it's gonna move twice its feed rate. I can can also do that with the spindle speed. So spindle speed, again, is the rotation in RPMs, revolutions per minute. So I can increase that by 200%, or how fast it moves, the feed rate through the material. So it's kind of based on like what you hear. If it's not, it doesn't sound right, if, you know, maybe, you know, you can really make some adjustments to this. Now, I'm gonna increase the feed rate, see what happens, slowly. So it's moving a little faster now. You can see the chip evacuation, shooting the chips out like a little rainbow. That's a good sign. I like the sound. You know, it is a soft material, so there's a lot of room for error here. It's a good sound. We're cutting multiple depths, like quarter inch depths at a time, so that helps improve this process as well. So again, you know, here's some manual overrides. You know, you can do during the process to dial your settings in and make changes to your code next time if you run it. Keep running more parts. Okay, so let's look how close it is to the vise. That could be concerning. So, you know, you really gotta like get your eye level to kind of really see how close it is to that vise. You do not want that tool to hit that vise. Okay, so we're gonna watch it closely, and if it does hit the vise, then obviously we have a problem we have to troubleshoot through, but let's see what happens. Okay, so it just dropped another level. Let's zoom in. It dropped another level. It's even closer to the vise now. Okay, so if this is the last pass, we're good. But if it has more passes than this, then we're not good. It'll crash. So it's dropping another level, and we're super close now. The only way we can really be safe is to do a feed override, get out of 200%, and really drop it slow, okay, on the feed. Because now, if it hits it, we'll have time to react, okay? So I'm down by 8% now. I'm gonna unpause it, and let's see what happens. So I'm gonna zoom in. I don't hear any metal on metal cutting. That's a good sign. Still above the vise. I can increase the feed rate just a little bit because I feel safer. All right, starting to cut on that new Z plane. So far, we have not hit the vise. Okay. So it's gonna go ahead and begin to wrap around. Oh, look how close it is. I think, you know, we said originally we're about 70 thousandths above the vise. That's pretty much what 70 thousandths looks like. Super close to the vise. I would not recommend being that close. You should keep your workpiece like quarter-inch off that vise at least, so you don't crash. Okay. So we're gonna increase, because so far so good. So we're back to 100. Okay, so our part finished and there weren't any problems, so that's a good sign. Hopefully I shared with you some troubleshooting methods to make sure you know how to prevent a crash and really evaluate the machining process and paying attention. So I'm going to open the shield up. We've got a lot of things to clean up. I'm going to go ahead and clean it. It's right in the middle. It's asking me, it's in the middle of the program, it's asking me to change a tool too, okay? So before I do that, I just want to clean up the area. Now, if you're sensitive and have allergies, you should have a dust mask or something, but I'm gonna go ahead and turn the vacuum on. Just kind of clear the area so I can see what's going on. Okay, now we're going to go ahead and do our tool change, okay? And by cleaning it up, it really prevents the dust from being blown around. So make sure you clean it up, reduce the particulates that you're breathing in, or you may be breathing in. And now we're going to put tool 2 in, okay? And we're ready to shut shield. And it says insert tool 2, which we did, not F5 to continue. So let's go ahead, go for it. So when I'm running it, I'm always ready to hit pause at any second, okay, to prevent a crash, or I'm always ready to hit stop, okay? Always paying attention to what's happening and evaluating, analyzing, and just ensuring a safe operation of the machine. So another thing you can do, you can analyze, you know, you've got 2,033 lines of code and we're on around 1610, okay? So you can kind of estimate, you know, how much more you have to go and where you are and, you know, how long we've been running it, you know, so you can really analyze to see if you go back to CAD/CAM and how to improve the time, because you want to decrease this as much as possible, because obviously time is money, and the faster you can make parts, you know, is going to improve your return on investment. So you always want to try to keep improving your run times by refining the process, optimizing. Okay, so the base is completed. I moved it into a quick home position, so the tool's out of the way. Now I'm going to open up the shield. I'm gonna clean off the space that you see here and remove the part. Okay, so I cleaned off the space. I'm gonna go ahead and loosen the part, loosen the vise, and loosen the part from the vise. And just the remaining amount of dust, I'm gonna just tap and just keep it all contained inside here. It's easier to clean and reducing the particulates in the air so you're not breathing it in. And there we go. So basically now the last part would take this to the bandsaw and just cut with the bandsaw along this edge so that we can release the part from the stock. Okay, so I'm going to remove this part from the stock using the bandsaw. A couple things you need to know. Never put your hands near that blade. In a line with the blade, always keep them outside. You can do that by using a push block or push stick, okay? So you never have to get your hands near that blade at all while pushing the material through. You can lower this fence or increase the height of it. And this stock is actually a little too long, so I can't push it through. So I'm just gonna trim this section off first. So I'm gonna line it up and just trim just enough out. But I also need to make sure that the measurement here, so it's 2 3/4 in the front, matches 2 3/4 in the back. And then I'm gonna lock this down so I get a nice straight cut. Turn the machine on, wait till it gets full speed. I'm going to use a push block from this direction, and then you can use a push stick in this direction. Just slowly feed it in. Okay. Always keep your hands away from the blade. Okay, several inches away from the blade. Slowly move out, turn it off, wait till the blade comes to a complete stop. Then go in and reach out for your parts, okay? Just some safety protocols so you don't hurt yourself or other people. Okay, now you can see, now this will clear this guard really easy. Okay, so I'm gonna release the locking mechanism on the fence, and now I'm going to line up and just kind of see, you know, I get a little different angle, but basically, you know, you want that blade surface flush with the stock surface, okay, to get a nice cut. Okay, if you cut too far in, you know, you're going to cut part of your part and then your bottom will be missing. So that's not good. So line it up properly, make sure your measurements in the front match your measurements in the back. You might have to check multiple times before you cut it, because you gotta measure twice, cut once. Okay, can't make changes after you cut it. So I've got it flush here. Okay, I'm gonna move the part. I'm about 3/8 in the front, 3/8 in the back. Okay, so I should have a straight cut. I'm gonna lock it, and when I lock it, the fence does move. So I'm just gonna check my measurements again. Unlock it. I don't like how it adjusted. So I'm just trying to maintain that even straight cut. So I'm 3/8 in the front, 3/8 in the back, and now I'm going to line up my stock again, and I'm still at a good spot. So I think I can remove the parts without removing any of the bottom. Okay, I'm going to start the material back from the blade. I'm going to turn it on and wait till it gets full speed and then I'll feed it using the push block and push stick. Nice and slow. Do not rush it. So I'm putting pressure in on the outside with the push block towards the fence to make sure it stays straight, and then pushing it ever so slightly forward. Okay, move my hands back, turn it off until the blade stops completely, and then remove your parts. I didn't cut my bottom out, so that's good.